Hello, people. Welcome to video number two. Video number two is going to help us determine a very common error that students make, or not determine, but it's going to help us with a common error that students make. And that is distinguishing between the phrase, we want to find the average rate of change, versus we want to find the average value of a function. Those are two different things, and maybe I should do them in different colors because they're different, right? And we're going to talk about this in context of number two here. So let h of t, which is I'm going to assume is a height function with respect to time, is given by this equation. H is height, haha. H is height in feet, and t is time in seconds. What is the average height during the first 3 seconds? First 3 seconds. Okay, so that means I'm going to take 1 over, in the first 3 seconds, that would be from 3 to 0. So the integral from 0 to 3 in the first 3 seconds of this function. Cool. Now, to practice our integration techniques, I'm going to say this is 1/3 times, and then we'll take the antiderivative of this. So this is negative 16 t to the third over 3 plus 41 t squared over 2 plus 10 t, and we're going to evaluate that from 0 to 3. And then I would substitute the 3, and then I would substitute a 0, and that would be the end of the story, right? Now here, I notice that when I do the second substitution, if I were to substitute a 0 everywhere I see a t, everything goes away. So really, I'm just worried about substituting the 3. So I substitute the 3 plus 41 times 3 squared over 2 plus 10 times 3. And whatever this is, that would be the average height, because we're looking for the average height. They gave me the height function, so I'm going to use the formula that we talked about up here in this bubble. We're going to use it because they gave me the function whose average value we want, right? We want the average height. They gave me the height equation. That's what I use. Now, at this point, I could do this in my head. I can do this on the calculator. But the moral of the story is we have the way to get the answer. Technically, this is the answer. It's not simplified, but we have the answer, right? That's different than letter B. What is the average velocity during the first 3 seconds? Well, now we're not talking about the height. Velocity would be the rate of change of the height, because it's telling me how fast the height is changing, right? So the rate of change of the height, that's what the average velocity tells me, or that's what velocity tells me. And if I'm looking for the average velocity, I'm looking for the average rate of change of the height, which means we're going to use this formula. Uh, Since we're given the function h, I'm going to use h, not f. So this is going to give me the AROC. This is the average rate of change formula, right? The slope formula. So here, this is something a little bit different, where I'm going to have to just find the derivative. I don't need to find the derivative. I don't need to find an antiderivative. I'm just going to plug it into my original function and use this formula. All right, so if I do that, let's see, if I substitute 3 in there, that's going to be negative 16, 3 squared, plus 41 times 3, plus 10. That's the first part. Minus, and if I plug in a 0, that's going to go away, that's going to go away, but I'm left with 10. And then divide that by 3. Well, I notice the plus 10 and the minus 10 are going to cancel each other out, so really I'm just left with this first part. And that first part, I believe, let's see, negative 16 times 9, 4, 5, negative 144, plus, that's 3, 1, 2, so 123, plus, oh, no 10, because I cancel out with this 10, right? This went away. Doink, doink. And then you're dividing by 3. So whatever I get out of this, I believe that's my answer. Is that negative 7? Did I do that correctly? I think I did. So wait, what are the units of this? Well, since we were looking for the average velocity, the heights are measured in feet, the numerator. The times, the denominator, are measured in seconds. So this is negative 7 feet per second. So in that window of the first 3 seconds, the height is decreasing at a rate of 7 feet per second. But that's different from the units on this one, because the units on this one, since we're looking for the average height, the units on letter A are really just feet. So here I'm looking for height, specifically the average height. On letter B, I'm looking for the rate of change because I'm looking for the average velocity, and therefore I have a rate type of a unit. There's a difference, and you're gonna have to read what they're asking you for, and then read what you're given, and then make the correct choice for which formula we actually need. We'll come back in the next video. We'll do number 3.